Just you know, before we get started, first of all, please put your cell phones to the side, but don't tell them off. Please, any comments, any questions you have on Cyprus. And okay, we have a live stream right now, so to everybody watching from YouTube, hello. If you cannot see the slides, we will post them on SlideShare. And just thanks to CIIM for sponsoring this event, as well as all the other events this year. And let's start straight to the point. I want to welcome Nicolas Pouparas. He is senior software engineer at CIIM. He's also a member of CIIM Nicosia, and he will be talking about how software is developing now.
Hello guys, good evening. Very nice to be here. There is a small issue here about the whole relevance regarding to today's event, but we can get how to go. It's a bit different than we expected. First of all, I'm a software engineer technologies and in Cyprus. We do as the most innovative stuff as we can do on the responses quite good so far. Mainly because of my other side projects. I am co-lead and co-designer on Icarus project. Project Icarus is and this is the topic of the whole thing. Facebook. Icarus is a complete theoretical study design of an interstellar spacecraft. The challenges are quite difficult in this one. It's not a directly or indirectly software project, let's say. It's primarily an engineering project. Of course, there is a software aspect to it. And we discussed about it as well. But I will guide you through the whole thing very, very fast. The project is clearly voluntary, but so far we have produced quite a large amount of research. As you can see, in 4 years that the project exists so far is quite involved in two international conferences as well, in which one we were awarded a grant by NASA. So, the organization of the project very quickly is divided into 20 modules. All these with all kinds of irrelevant software, usually like astronomical target or structure and material software. The bulk of the research is directed to primary propulsion, which is the main concern of the whole project and the most challenging aspect of it. However, and here is where the software business is considered, we have two modules that are directly relevant to everybody's business, which is communication evidently and computing and data management. Because in order to do something about these 4 languages away, it means, for example, regarding communication, you get 8 years between request and response. So if you are using those web services, the Internet of Things, get this, get that. You need to think very clearly about it. However, for those who are interested, that they get from behavioral and networking, I think you'll find more interesting. So, about software. What does that mean? This means that in regards to the research aspect of the project, we do not actually develop, we do research on software. The most challenging aspect of it is resilience. The scope of the mission has to be the travel time has to be less than a century, which means that we have to create software that will actually be running more than the history of computing itself, which by definition has not been done yet. However, in this area we have some commercial products based on aspects of this research. So it's not all that bad regarding the research. So what we do, how we do things, low tech, which is a bit counterintuitive, if not ironic, if you consider that this is as close to the enterprise or galactic picture of stable spacing. You get what do we use? First thing, the most important, email. Yep, the glue of the whole thing. Consider the fact that the bulk of the team is astrophysicists and double PhDs and this kind of thing. Those people who physicists have not actually time to consider going through processes. They have to do their own creative stuff. But what is very nice about it is that email actually works. Because everybody, especially in the scientific community, the one thing we do is that we will definitely check the email. You can't really go wrong about it. However, let's get a bit more technical. We're not talking about an email list. No, we are talking about copying and pasting all the recipients' email, or from the between a thread to a new thread, this kind of thing, which can get very messy. But that's production, not walk around. Well, consider that the main aspect of e-commerce prototype is what we would name and document production. So, every time someone has a document, new paper or whatever, the creation happens through email, which we consider is a mess. It's a mess. No kind of version control. The most the document management system, something like that, very remembering. It's a bit chaotic, but however, as previously shown, so far it has led to more than 100 papers and presentation and all kinds of things. And you know what? This is a complete project. Nobody can pay for it. So actually, it's not that bad. Sounds bad, but no. Our next tool, forum, which is only marginally better. Our forum is a private forum. But it's pretty close to 8,000 members of friendly because we have all kinds of members regarding the degree of participation. So even council member, but only the core does. The only difference, as you may guess, is that things tend to stay there and only to change a lot. So in order to facilitate the whole thing's biggest problem, which was the documents and the files and this kind of thing, we use our next tool, the robots. Actually, very handy. It saved the whole team lots of time, still not version control, and wait, but it was very nice, not only for the assets of the team, but also for the paper system. The problem is that we can easily share this with everybody on a per case basis. So it's not that personal, but much better than me. We have a website, which is okay, it is nice. We have almost 5,000. The main drawback of this tool is that it's not for us to make the whole research available public. It's not something that's private, after all, everything is peer reviewed. But it's that you can't have astrophysicists doing websites. So you can't have an astrophysicist. You know, you go to the website, you upload this kind of, doesn't work like this. Still, you can find quite a lot of stuff there. It's a nice overall presence, but we could do better. Now, let's go to the actual what is the tools they use. Number one, mathematics. I think that most people would know that. The reason for this is that since most everybody is a professor at some university or something like that, they only have the licenses from the universities. Some of them do not, however, and some of them will consider using the Volkswagen Alpha engine to purchase an API, so everybody will develop them, will develop specific applications to help the physicists do this kind of thing. However, it was concluded that it wasn't really needed. It's very expensive, actually. You'd be surprised. But still, Mathematica is a mix of the two. I think it's the best that you can find for this kind of thing. Because astrophysics doubles mathematicians. So, but the winner of them all, one, I don't know, to rule them all, is yes, very ironic. I know you guys were expecting to hear this very logic thing, but consider this. Consider the irony we are talking about interstellar, which is something that consider that the Voyager 1, after 30 years of flight, just left the boundaries of the solar system. So we are designing things that is going to be 100,000 times faster or something like that. Yes, we can say. It's the irony of the whole thing. However, it's very useful. It's a testing and do anything, actually. It's very useful for physics. What they have to do is, as I said in the start of the presentation, the most challenging aspect is the primary propulsion, which means some mass energy calculations. So, in order to send this mass with this velocity, how much energy do we need? This kind of thing. But we need to accelerate. Okay, so we need to break down, but we need more energy for this kind of thing. Which then means that doing this kind of fuel means additional energy for accelerating. And it's this kind of thing. So, what do we do as a physics? They put the mathematical model down on Excel because it's very easy. You know, you change one value, the things corresponding, and have the ease of switching the engine types. So there are four, I think, engine types at this point. So there are fusion reactions, but you can pick your kind of reaction, and it has its own different things. So it's very easy for them. And this is actually where the real software process will begin. You can see this is one sample of just one tab of the whole mathematical model we use. You know, that's perhaps different thing. That's not look that different from financial aspect actually. Let's look very close to see that it's about joules and not energy and not currency. So what we actually make, we have to take these models they use for the deployment. So we can have the spacecraft simulation, which will simulate the whole thing from engine reactions to everything, the emission scheduler, all this kind of thing, and put it on software. Why? The accelerator is good enough. Well, it does a big, but it has one major drawback among others, that it does not do iterations. For example, they want to test a range of values regarding the payload. They want to see what code energy was out there, it will change the payload mass. It would be easy to use a simulator to do this kind of thing. So, how are we going to do it? Personally, since I am very good at software models as well, and coming from the Microsoft side, long before it was started. Anyway, and since it's a major platform selection at this point, besides the fact that I'm coming from Microsoft, but the of C# and F#, which is ideal for our case, we can use the C# whatever you want to name object-oriented model to have the different specific parts, which we can do in Java or whatever you want. But for the calculation part, we can use the functional F# paradigm. And those who find excellent because they are both CLI languages, which means that it's a good situation for us. Now, we have organized a team also. By the way, we have made some proof of concepts regarding that during the past couple of years in cafes and this kind of thing, because it's a bit difficult to get with one another, and doing this kind of thing through email, as you said earlier, it's not that easy. In Skype, you can get on Skype. Some you can get, but not all. He says, I am not a physicist to understand this quantity mathematical models. So we have to follow the thing first and discuss the whole thing. Which means that, okay, if it was a space cowboy project that was all alone, I guess I could do without, okay, I have my but we have to work in. Since Project Nicosia is again a state voluntary project and we do not have any fund allocation for IT infrastructure at this point, it's all up to whatever we can get for free. So, the very nice part because this is tightly coupled with the academic community, we have a range of Microsoft Dreams part. I don't know if you know it's Microsoft's free offer for software for universities, for students. And most everybody in the team has access to this program, which means virtually access to everything. For example, we have access to Team Foundation server, but we don't have anywhere to put it. Perhaps we can say someone who does not need the server, so we can send it from the out. Personally, I think it's a bit of a hassle at this point. So I'm doing, at least for personal growth, this kind of really big package, which is really excellent. And by the way, Visual Studio 2013 has excellent key integration into the environment. As far as the rest, 3 points, which I think are the most crucial for the analysis testing and the performance. Performance will be a bit for the developer. We do not intend to have something, some external server or something like that, or automated process performing this kind of thing. It's a very nice process for bigger projects. This actually is complicated, but it's a small project. It's not that big. I mean, in theory, you can handle this. But it's not something that we want to waste time on setting up servers and we can for this kind of task. Everybody can do it accordingly. Okay, it's a bit brave at times, but among a limited number of people, I think it's easier for the big leader to coordinate the whole thing rather than, you know what, this build server is not working. Let's play the idea that we don't have to do this kind of thing. This is the process that we will actually start very early in January. I think, I'm not sure about it, we're already in the 5th year of the project. It was a 5-year-old project. And we had an internal competition about which engine design should be used. And I think that there is a consensus now about it, I'm not sure. So if this is available, we will probably start on it. And actually, it's a very nice opportunity as well. I heard stories about a guy in NASA actually, which the only reason for he was a physicist, but the only reason for him getting promotion was that he actually produced the software he used. He needed it. While everybody else was doing the thing in himself, he created the software. So everybody, this guy is more for that, some kind of director, something like that. So why not? It's a very nice opportunity and very good for experience for us both here. So how can everybody contribute? As you can see, we're still going strong. We're still Project Nicosia may be close to an end, but we have another 5 to 6 side projects other smaller related to starting. So if you think that you can and want to help and learn something in the process, because especially research is very rewarding. You get to read all kinds of stuff that you didn't even know existed. You didn't think a system engineering. Also, let me just put a simple plug here. If you are interested in the space exploration aspect, especially for software, this kind of thing, Cyprus Space Exploration Organization is going to hold the keynote foundation event. And if you want more information about the which is the guy behind this, and will be mostly directed to, first of all, whatever is relevant with Cyprus, especially in cases primarily of education and research and all these kind of things. So even if you have something crazy that you want to do, a project or whatever, go in the house and just ask it. And it's to the stars. From the garage all the way to the enterprise. Thank you.
So, Spacecraft, Microsoft tools, and new package. Quite interesting. Let's come back to Canada. Our next speaker is Alexis. Alexis is a co-founder of Cyprus, and he's also a software engineer, which is a platform for anyone to open a free online store. And Alexis is setting up a presentation. We will have can you hear me? Okay. We'll have a Q&A session at the end with all the speakers. Okay, let's welcome Alexis.
Hi everyone. I'm just going to start here because this thing's not working. Okay, yeah. So, I'll say it said. This is not working. Anyway. Okay, so I'm a bit sick, so sorry about that. You can find me on Twitter, AlexMick, and that's my website, alexmick.net. I'm a software engineer at Tiptail. I moved from London to Stockholm to Stockholm. It's been great. So what is Tiptail? Tiptail is a startup, a Swedish startup that allows you to open a free online store. So if you have clothes to sell or whatever, you can just go online and open a store. Wired magazine told us that Tiptail is a Tumblr of e-commerce, which was a pretty cool thing to say. So our growth, we've been going on, I think, for about 1.5 years now. We launched publicly. We now power more than 30,000 online stores. We're a small team. We are 15 people in total. We are about 9 engineers. 6 of them commit to the project every day. We also have a developer relations team and the CTO that's a bit out of the code base now. So what I'm going to say works for us. I'm not saying that it will work for you, and I'm not saying that it can work for us in the future as we grow, but it works for us now. So we use Git. Who uses Git here? Excellent. So Git is a decentralized version control system, which is much better than SVN. We host the code on GitHub. So I don't know if you can see that. Git clone, github.com, API Explorer is one of our open source projects. Our code base is 99% Python, which is excellent because we love Python. And we hope you love Python. It works for us. We host everything on our web services because we love the cloud and because we want to start servers from the command line. So a couple of weeks ago, we had an incident that So half of our servers went down because of an Amazon problem, and we spun up half of the infrastructure with just one command on the command line. It took us about 10 minutes to do that, which is great. So imagine you have the same scenario with like real life machines, ordering them, blah, 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 you know, the next anyway. So how do we work now? Right. XP, Scrum, Agile, Pairing, Kanban, we just say whatever. We just do whatever works for us, and we are not, you know, very like focused on one methodology. So yeah, we do whatever. We have a Kanban board in the office, which we use just to see like how the teams are progressing and how they communicate with each other. But it's a very high level thing, so we don't really aspire to any sort of So let's get down to technical now. Always developed in a production mirror. So we use Macs, but we always develop on Debian. So we virtualize Debian on our Macs because that's how we run production, and we want to be consistent, and we want to have repeatability. So the same way we set up our production environment, that's how we set up development as well. To do that, we use a tool called Vagrant. I don't know if you guys know Vagrant, which is basically a wrapper around a hypervisor, like VirtualBox, which is free, but we use VMware Fusion, which is paid and much better. Right. So, our branching model, we just say keep it simple, stupid, or KISS, that's how and we if in doubt, we always branch. So we create loads of branches, we develop in branches, and then we merge that in master. So this is a very simple methodology. When we want to create a new feature, when we want to fix something, we create a new branch, and then we merge it into master. And then when it's done, we just merge master into production, and the production branch is what gets run in production. So master has to be always deployable. Master should not be broken because that's what's going to go in production. So whether it's master 5 is 5. So say it goes on for production. So you can see like these are some of our branches. We have loads and loads of branches on GitHub. So I don't know if you guys use pull requests, but we love pull requests. Each branch ends or even starts with a pull request. And this is an example pull request. Obviously, I've redacted the very, very secret things there. So let's see. So we do, when we're going to start a new feature, what we do is we start a pull request even before we develop any code, and we just say that it's a work in progress, and we just prefix it with WIP there, which means like this is not ready code, obviously, and I want your input into what I'm doing, so we can see progress. Then a pull request enables discussion. So if I start a pull request and I have some ideas, some points I want to start to discuss with my teammates, and I just write it there, and everyone just starts discussing. A pull request also enables code reviews, and that's how we do code reviews, because we can look at the commits as the person that started the pull request, commits code. We can look at them, we can comment on the commits. You can say, oh, this is maybe this is great, stuff like that. And also, we have a setup where our tests get run on every push, on every Git push with the GitHub. We run tests, and we get that green line there that says, all is well, your tests are passed. So I don't even need to go and say, are the tests passing now? What is this? So I always know where, okay, the tests are passing now, that's great. But the most important bit of all is knowledge sharing. Because by doing this thing, right, we sort of eliminate or try to eliminate, single ownership of code. Because everyone is free to go and look at the code, comment, and learn about what that person is doing. So, we basically use the bus factor. Right. So what happens when a pull request needs to get merged? We have a culture of trust. So we only need one person to say, looks good to me, or let's get this merged. We don't need to do like 2 or 3 people need to say this is good. We just trust our colleagues and we trust. If one says this is good, then yeah, you're ready to ship it. It's ready to go. We use GitHub issues for bugs and for feature tracking. We use labels and we use colors to denote things. So you can see, I don't know if you guys read it, but we have bluish labels with like sort of product. Then we have more dark colors for the level, so it's prioritized if it's a critical bug. And we have types, bug or feature. So that's how we can slice and dice our issues and see like what each one is and what it means and stuff like that. Okay. So how do we do integration? Now we've done like the feature, this is nice, how does it go into the main code base? And we basically follow the loop, right? For each push, we build, we test, and then we notify, and maybe we can profit from that. Build and test are sort of the same thing because in Python there's not really a build step. This is our continuous integration service. We use a hosted service called Circle CIIM, which is really great if you want to eliminate the hassle of running your own integration service like Jenkins and crashing all the time. So we use this quite cool hosted service. So every push, every branch, Circle runs our tests, and then you can see that green success, red failure, and then that goes, then notifies us. So we use HipChat for chat. So we get a notification HipChat saying success. We also get an email that says success. But the coolest bit we've done is that this is red and that's green. So our desk lamps are hooked up to our integration server. And if someone breaks the build, the whole room becomes red because all of the lamps become red. So then we know who to blame. And then when it's fixed, the lamps become green again. Right. So the last step is deployment. And how do we deploy? We deploy many times a day. We think that release cycles are slow, and we want to get features and bugs as fast as possible to our users. So what we do is iterate, validate, and polish. And many times we actually scrap things as well. So we have this little software here we call Penguin that helps us with our deployment. So by issuing a command Penguin C4 means deploy, what Penguin will do is it will split our infrastructure into two. So then we do no downtime deploy. So we deploy on half of the machines, we take them out, deploy code, put them again, and we check if the code is working, and then we can issue yes, now this is okay, and then we deploy to the rest of the servers. If there's a bug, then we do a rollback, so the half that we get the code gets into production, and we roll back the code manually on the broken half. So we sort of ensure that there is no downtime. And it's not perfect. I mean, it works okay now, and it's probably much better ways to do it. But for our team size, and it works anyway. So I think another very, very important thing is communication. So we chat a lot in HipChat. Everything we do, we revolves around HipChat. We email a lot. We have two main email lists, let's call them. We have echo@tiptail.com, where we announce features. Jeffrey's shipped us something really awesome. We just announce it to everyone because we want the whole world to know. We also have Office Gossip on Echo, and then Tech is mostly for discussions, link sharing, and we also take some quick decisions on email. We have this thing called decision meeting. So if someone is input from other people for something he wants to build, we discuss it over email, and then we have a week later saying, okay, this is a quick decision now, so we take it a week later. So all the sort of the email thread builds up that meeting. We have a thing called Project Sim, where we do every Monday, where each team gives a summary of what they've done, and what they plan to do. And the main reason we do this is to avoid two teams doing the same thing, right? So to avoid what do you say? Yeah, overlap. Thank you. To avoid overlap. And yeah, the last really cool thing we do is called retrospective, which you know Scrum, and so it comes from Scrum. We do this bi-weekly, and what we do is just getting a room. We started playing with the tech team, and now we actually do it for the whole company. So we get a room, and then there's two sort of sessions in the retrospective. One of them is we just put post-it notes on the wall on things we believe we've done well in the past 2 weeks. And then the other session is what we think we can do even better. So the important bit is even better because we go at it with a positive sort of line of thought. Instead of saying what we did bad, we can say what we did better. And that is, I think, a bit easier. Right. So to recap, consistency, work in progress, branching, trust, simplicity, Python, Git, discussion, retrospectives, cloud, deployment, code use, and code questions. And that's how we work at Tiptail. And there was a thanks there, but I don't know where. Anyway, thank you very much. And we're hiring if anyone's interested.
Thank you, Alexi. Our next speaker is Michalis Vassilis. Michalis works as a software engineer at Twitter. I think you all know Twitter. Somebody doesn't know Twitter? Don't think so. Michalis is actually in San Francisco, so you have to give us a few minutes to set it up. But he will be with us through Google Hangouts.
Hello? Hello, Nam. Hello? Hello?
Tela.
Hello? Ακούς με?
Ναι, εσύ.
Ναι, μια χαρά.
Ωραία.
Ξεκινώ.
Ναι.
Okay. First of all, I swear I was gonna make more jokes, but Google made me read and agree to their terms and conditions, which involves me being recorded, and also the shocker that there's gonna be people that I don't know. So I cannot use any of the effects. Oh, wait, I can, but okay, I'm not gonna do them. So basically, a bit about me before I start talking. I was born and raised in Larnaca. I did the army like most people did. Went for undergraduate education in Boston. I did my master in Boston as well. And I recently moved to the West Coast. Most of my education was basically in computer science and mathematics. So now it makes sense that I'm working at Twitter. They're paying me extra to wear this. And basically, if you want to work in companies like Twitter, I mean, this is true for most companies, but especially for Twitter, is you have to be at the headquarters. That's where all the action is happening. That's where most people are. And even though they have some satellite offices, the biggest percentage of people works at the headquarters. So that's why I moved to San Francisco in California. Also, the weather is a bit nicer, so I like it here. I was gonna talk more about how code works at Twitter, but I'm not sure how technical the whole crowd is. And a lot of the people I was gonna say, Alex mentioned them already, so we're doing a lot of things similar to Tiptail. So what I'm going to do is first give some sort of a high overview of the company, what the basic needs are for the company, and just put you in the right context because the scale at Twitter is a bit different. The reason I'm not gonna go too deep is that I cannot talk about all the technologies we're using. Otherwise, I'm gonna get fired. And then yeah, I just want to keep it as non-technical as possible while conveying all the information. So what I'm gonna do is first give an overview of the company with some statistics and numbers. Then I'm gonna talk a bit about the structure of the company and how teams are coming together. And then I'm gonna talk how code is developed and maybe some closing facts at the end. So basically, what does Twitter do? I mean, I'm sure most people know what Twitter is doing, and most people think it's just posting a line that's 140 characters long. And if that was the case, then we wouldn't need 2,000 people working for us. A fun fact why it's 140 characters, side note. It used to be completely on cell phones, so it used to be a message broadcasting. It wasn't online, it wasn't mobile. So since every message is 160 characters long, then we just had it 140 characters and some extra characters for metadata. But these are not the only products that Twitter has. We have a website called business.twitter.com, which is not directly related to the product, but basically, if you want to advertise anything on Twitter or if you want to have a business interaction with Twitter, then you have to go there. And that's where we make most of our company, not from the main product. We also we hire a lot of companies. So one big company that we acquired is Mopap. It is actually the world's largest mobile ad server. So most advertisements on mobile go through them. Vine is owned by us, which is a video sharing application. So basically, Twitter is not only the core, there's a lot of other side products for the main product and also just completely different products. There's a lot of collaborations happening for Twitter. Twitter with big data analysis companies, Twitter with marketing companies, Twitter with TV. So there's all these things going on. Some fun numbers about Twitter. There's about 200 million plus active users. Biggest percentage of them are on mobile. So Twitter should be as easy to use as possible. And most of the time it's just quickly updating on what's happening. So you want to be as mobile as possible. The size of the company, we're about 2,000 employees. A bit less than 1,000 are engineers. So less than 50% is engineers. And having said that, I just want to give some examples of how big the scale is at Twitter. and how some problems that may sound trivial for most companies, when you're talking about this scale, even counting clicks and counting how many people viewed your tweet become a problem. So, for example, a rough estimation on how many tweets are going on per day is 1 billion tweets per day, which means divide by 24, divide by 60, divide by 60 gives us about 11,000 tweets per second. We also have to handle some bursts of tweets, so the maximum we had was 150k tweets per second for an extended period of time. And these things happen when there's maybe an earthquake going on, maybe a TV show going on like Games of Thrones, and some other, maybe some like riots in Egypt or whatever else. And every tweet doesn't just have 140 characters. 140 characters is mostly what people and users are seeing, but we have associated who is the user that tweeted, what's the location, what's the time, and so many other metadata. And even more, like for every user, even though the user never input any information on what his gender is or where he's living or anything like that, we infer for the user his gender, what are his top interests, what are the main locations that he's usually posting from, and all this information. So in order to store all of this information somewhere, in order to handle them quickly, we need a lot of in-house products. We need a lot of power, and it's usually two problems that come with scale or with any problem. It's one of them is time, and the other one is space. So basically, the space is okay. Where do we store all this information? How do we do it efficiently? How do we do it redundantly in the sense that we have backup just in case something goes down? How do we retrieve this information quickly? Another problem is like, okay, let's say I'm gonna tweet now, and I have followers, hopefully all over the world. I don't, but let's assume I do. It has to go to all of them instantly, and all the information that goes along has to be propagated at the same time. So it's huge volume to store. The latencies that we're working with have to be as small as possible, but you have to go through some infrastructure problems and networks. And basically, yeah, that's it with a big scale problem. Let's see what else. How about the structure of the company? The structure of the company is as follows. First layer is infrastructure. Second layer is platforms. Third layer is the actual product. And on top of everything is revenue. I'm actually working for revenue. Infrastructure is the low-level thing of how everything works, like who is managing the data centers, what kind of networks are we using, how everything is put together. Platforms is an abstraction on top of that, so most engineers don't need to worry about any of those things, even though we should be aware of what's happening. And then on top of the abstraction, then people start building products and features on the product. And given that we have things working, then we need to start making money. So then we need products on top of everything, which involves data analytics, it involves monitoring, and it involves a lot of other things on how to make money out of our product, basically. I'm in the revenue team, and I'm doing data analytics. So basically, my specific position is how is everyone using Twitter? How is everyone interacting with the advertisements? How well are the advertisements that the campaigns are doing? Which is information that, I mean, basically the ones who pay us really love. And now I'm going to talk a bit about how code works at Twitter. And basically depends, and depends is a very vague phrase that I hate to use, but it actually depends because a lot of different teams do it differently and a lot of individuals do it differently. So I'm going to talk how I'm doing it, and I think it represents a big portion of the company. First of all, you get some sort of all three flavors at Twitter, both the startup, both the giant, and both the open source, and I've worked in all three projects, and I've been here for like 3 months. But I'm going to talk mostly about how does a giant do code, because the other people talked about the other ones. First of all, it's very collaborative. We don't have too many individual projects going on. There are some individual projects if you have an idea that you want to work on, but for most problems that we want to solve, we need the teamwork. We need the teamwork because we need big projects done fast. And we also need them to be reliable. We need them to be checked. So basically, how do I start? Most of them as well. I mean, I'm not gonna start a huge project on my own. Most of the things I'm gonna do is extending already existing code, a huge code base, tens and hundreds of thousands of lines of code, and my team is gonna work on a small part of a bigger project. So for this already, I think people should start thinking that we're using Git. Git makes sense because it's one of the best code management softwares, and it's basically the golden standard that is being used in all the big companies that I'm aware of. Sometimes like 2 or 3 people might be working on the same branch, but usually it's just every person for everything that they want to do. It says, can you hear me? Wait. Hello? It says I'm experiencing problems. I'm not, well, let's see.
We can hear you. Not anymore.
Okay, cool. So Google thought I had problems. I don't. Yeah. Cool. So everybody is working on his branch, and once you're done with your work on the branch, then you upload the branch for review. So once you're done with whatever project you're working on, your branch is up, and 2 people have to review it and give it a go. It's almost never right the first time, so you upload it first, you get the feedback from everyone. We have automatic systems for review board that makes the interface very nice. And then we basically interact through the review board to figure out how to fix the code. And then once you get 2 shipments from people, then you can go ahead and submit your code. Then you submit your code. There's a lot of automatic tests that are happening before it gets merged to master. And then once it gets merged to master, then in a sense you're good to go and other people can use your code, but you're still not on production. So in order to do deployments, we have particular engineers which are called site reliability engineers just for this purpose. For most deploys, there's a lot of things going on, so specific engineers are just handling all the deploys. However, like almost every person has to do his own testing. We don't have test engineers like other big companies. We're still like kind of mid-sized, so for most things, we write the code, we write the manual tests, then once everyone approves, it goes through some basic automatic tests, and then it gets merged. So that's the basic process for every single person. And then you have other things as well, though. Like so far, I've done some small hack projects with either a few people in the team or a few people across teams. These are moving. The good thing about that is that you can still move fast. You can move agile. You have all the benefits of a startup. And if it doesn't go well, you just throw it away. You just start fresh. You can change teams, whatever. The very good thing about that is that you have a super strong environment and infrastructure because you're basically a small like team that's like a startup at Twitter, so you have all the resources. So basically you have the flexibility without the problems. And then I've also worked on some open source projects as well. So we have some in-house languages being developed, but some of them we actually share it to the public, and we actually welcome the community to help them and improve them and make them faster and extend them and everything. So for example, I was working on a particular language called Scalding, and this helps you do Hadoop jobs, basically queries and big data much faster and more efficiently. And for that project, I used GitHub a lot. So almost all our open source projects are on GitHub, and we usually like to share stuff. And now, when it comes to the general topology and infrastructure, I wish I could say more, but I cannot talk too much about it. But almost everything is in-house. You can imagine something extravagant. Multiply that by 10. It's like multiple data centers, backups everywhere. Everything is distributed. Everything is just crazy. And then one of the things I can talk about is I guess it goes along with the nature of Twitter. Is one part is real time and the other part is complete history. So basically, at Twitter, we need to be able to know everything that happens. So that involves complete history, and you have to be consistent. Like, we don't want tweets to disappear or interactions to disappear. But at the same time, a lot of things happen real time. So in a sense, we have a replicated logic for something reliable that's for the complete history, and something that's super fast and super flexible, and let's say it's using cache and other things to handle a lot of real-time things. And that's the main thing, but we also have some Hack Week projects that are here and there. So basically we have research going on. We basically have almost all possible code paths that you can, code development paths that you can imagine. So that's pretty much it. Yep. Clap. Yay.
So we need.
Questions. Okay. Can you hear us?
Mihaly, can you hear us?
Hello? Yeah. Hello?
Ακούσουμε. Mihaly?
Yeah.
Έλα.
Hello? Mihaly, ακούσουμε. Μπορούμε να το κάνουμε επάνες ερωτήσεις για εκείνο. Dimos, Alexei? Okay, if Mihaly cannot hear us, we can try and type in the questions. Questions? Nobody? So you understood everything, you have no questions?
Crystal clear, everything.
I'm not a programmer, but I was.
Okay.
I'm on the business side. I'm on the business side, and a lot of things that we do when we need development. The biggest problem that we have is how do you manage the coding from the perspective where we are in a small market sector. If your developer leaves, somebody else comes in. How do you deal with that continuity of the development work?
Are you talking about different vendors?
I own a business and I want somebody to develop a code for me, and that somebody at some point leaves and leaves everything. How do you deal with that?
Either you have guidelines or you review your employees' code regularly. I think there's nothing else you can do. If you have guidelines that your employees have to use, if you have guidelines that your employees need to use, if you have guidelines that your employees need to use, there will obviously be some kind of compatibility on the long term. On the other hand, reviewing, having someone more stable, if you are suspicious about your programmers, having someone more stable review the stuff, it's also a very nice thing to go around. On the other hand, if you are talking about an existing code base or a new project, there are two different things. If you have an existing code base, it's much easier for everybody else to follow it in the name of consistency, which is a very good practice for the future. Besides this, I don't know.
Are you talking about when you have, let's say, a freelancer doing some of your projects and then he leaves? Now, how does the next one take over? Is that the question?
I mean, it can be that there are companies, something who works for you, and then they leave to go to some other place. You are a partner, you leave to go to Stockholm. For small companies, how do they ensure this continuity?
Okay.
You know, I understand about the guidelines, but if you are a small company, you don't have the expertise to actually follow the code yourself.
Yeah.
I think it's a very real problem that a lot of small companies have.
Okay, I haven't been in that position, but I'm going to answer. I think it might make some sense. So I think it's a matter of trust, mostly, right? If you think that you don't trust the person, then you could always sort of bring someone in, maybe like a friend of yours that's technical, or maybe an external advisor, to review the state of the current code base and tell you what he thinks, for example. Okay, is this a maintainable piece of software or not? If it's not, then you need to take measures, right? The person you have there, obviously, if you're a small project, then it's kind of hard to write documentation and code at the same time. But I think that's always a good thing to have. And you, even though you probably don't, you may not understand what the person, the technical piece, then you should strive for the developer to write some documentation for the next person, or to explain procedures and stuff like that. I think it's very hard though, right? If you work in the process, it's very hard for people to take over another person's project. But I think proper documentation and some sort of supervise a bit the process and code, then maybe you can have a smooth switch. I'm not sure if that is a good answer, but yeah.
If I may ask, for a startup company, would you recommend for the developers to start using versioning system from right at the beginning, or could it come later on?
Oh, maybe before the beginning. I can't even imagine not using version control systems. That's like so 2000 late.
Can we ask how many here are using versioning systems for development? And which one would you recommend?
Who's not using it? Who's not using it? This is the question.
Who's not using it?
Yeah, actually. I'm almost equivalent in Git.
Yeah.
But I think it's a matter of what works best for your team. If you have people that are experienced in SVN, I don't see any reason to sort of force Git on them, right? So I think it sort of depends on your experience, of the team's experience.
Better than nothing. Better than nothing. Anything is better than nothing. Eat anything.
Ali? Ali?
Hello?
Can you hear me?
Yeah, well, I'm on mute, so people put me on mute and I'm mute, so I'm not sure.
Okay.
Okay, so now I'm on?
Can you hear me now?
Yes.
Did you hear the question?
So can you repeat the question close to the microphone?
Okay, so the question was if you would recommend people using version control from the start, or just not using version control and then maybe using it later in the project.
Yes. Well, it depends again. I think I would say yes, just because in case you don't know it, I think it's the best way to learn it, like just by doing it. So even if you start, let's say if you're 2 people, then you don't really need to. But if you're 5 and more, then it's a good way to, for those who don't know, to start like learning using it, and also for everyone who just hops on the projects that people are working, just makes it easier. There's not too much overhead to use Git. It's basically like once you kind of get the grasp of it, it's pretty easy to use and very lightweight. So I think it makes sense to use it from the beginning. Yep, that's pretty much it.
Perspective again. What do you think would be the perfect team? Like, let's say a leader who will check the code, everybody checks it, everybody submits new code, everybody tests it. What's the perfect infrastructure for the development team for a startup company? Like have a chief technology officer, co-founder, which will be responsible for everything.
I think ideally you would have a technical person in the founding team, because to actually avoid the situation you mentioned before, right? If your co-founder is a technical person, then you avoid the employees leaving and the continuity problem. Then in terms of the team structure, I would say there needs to be a leader. I've worked in 2 companies. One of them didn't really have a leader in the team, and then now we have a CTO. And I think things are much better with the CTO, just because you sort of avoid talking about things and waste time, because you want to reach a consensus, and then everyone has their own opinions. But then you want to be nice to their person, and you don't want to say, like, no, that's the way we can do it. Whereas if you have a leader, a CTO, who is respected among the team members, then I think it's much easier to resolve this sort of conflicts. And then it's a matter of experience as well. If you have someone that's very experienced that can lead your junior developers, that works better as well. Then our team is, we have a CTO, then the whole team, the other team, is full stack people, so we do both front-end and back-end, so because we're a small team, we don't really think that we should have specific roles at this point in time, so we do everything. But yeah, as we grow, then we probably need specific roles.
You do both development and testing.
Yeah, we don't have QA people. We just write unit tests and integration tests, and then, as I showed before, we run the most of as I don't push code. Yeah.
So, how important is testing in your process? Do you wait another really high coverage? Do you take a testing approach, or do you test later?
Well, from the Icarus perspective, I can't really answer this one because we don't really do the stuff. Well, for the researchers, it's very important, and perhaps this should be also applicable to code. Everything is peer reviewed. Everything is reviewed by everybody, and it has to be solid in order to go out there. I don't know how easy it is. I have to think about how easy it is to do it with code. But as far as testing goes, well, there is this whole debate going on about test-driven development, this kind of thing, and it's really a question about not losing the forest for the trees or something like that, but I don't know the exact English phrase. I think this is it. However, testing, and I think especially regression testing, is crucial to products that one step before production, especially regression testing. I would prefer having people to do it, but I think that nowadays, especially in the startup ecosystem, you can't really afford paying people to do this kind of thing. I don't know if anybody of you guys have some thing for crowdsourcing testing and this kind of model going on. It would be really nice to do that, but can we really trust this kind of process for something that we are delivering to the customer and getting paid for? I don't know. But still, testing, for me, regression testing especially, because it's a matter of quality. Okay, let's go back to the space now. In order to do this we talked about resiliency. One of the sectors that we reviewed extensively, which is very important for the software architecture of the whole thing, is software resiliency and how this applies. Now, those studies globally, and we're talking about things that haven't got anything to do with software. You can see that systems engineering. Both things are applicable, and if you are from the software space, you'll understand it. The 2 most common causes of accidents worldwide regarding industrial accidents, whatever, have to do with too much complexity, tight coupling, and hand in hand with tight coupling, you have low cohesion. If your systems are coupled and this kind of thing is, perplexed and complex, this kind of thing, then it will be very easy to break, and most often in catastrophic ways. And the same goes for software. It's the same thing. It's a system. Now, regression testing, even that you are working with a few other people. Are you really aware of the whole system? Do you know the whole system? Do you know the whole thing? For very big software systems, perhaps there may be 15, 20 different components. I know you heard about Twitter. It's a whole thing that who knows the amount. It has to be, there are perhaps hundreds of components. Which ones are the coupled? Who is the guy that knows how everything works? What kind of regression testing, something in the size of Twitter has to do? Imagine something breaking up on a seamlessly, totally irrelevant, unconnected thing. This is the major source of I mean, okay, of course you have to do developer testing. Of course, it would be very nice to have testers as well, but my mind is on regression testing time. Because you know something, if you hear bad stuff from the customer, it's not about testing this component specifically. I mean, of course, this is completely unprofessional. You have to test this component, but it's something else that breaks down most of it.
Mihaly, do you have anything to add? Did you
for testing?
Yeah, the importance of testing.
Yes. Okay, yeah. Super important. The only thing I have to say is that testing should be just enough. I mean, it takes a lot of time. I've been testing for the last 3 days because I have a big shipping today. I mean, we have to code and we have to test. So we're not supposed to waste time in testing, but testing has to be there. So we put all the effort to just like write the right amount of testing, make sure it works. And since it's a huge scale, we cannot test out every single thing. The most important thing to test out is the interface, how your part of the project interfaces with the rest of the code. You can do as detailed testing as you want for some specific things internally, and you should, to make sure it's working. And you should also do some manual testing. But basically, you have to make sure that your input to the part of your code and the output makes sense with the rest of it. And some of that is handled automatically at Twitter, but a lot of the things you have to do is just you have to write your own test to make sure that works. So just enough so that you don't spend all your time testing, but it definitely has to be there. Because, yeah, as the aforementioned, if one person breaks something, other teams are going to get affected as well. And it does happen. Like, sometimes I cannot work for 2 hours because someone else broke something, he has to fix it. That's why it's good to have other projects to work on the side. But, yeah, testing for sure.
So the scrapping bit, we've lately took a more data-driven approach to things. So we try, whenever we ship, we try to measure it, and that determines if we're going to scrap it or not. If it doesn't fit the metrics, then we're going to scrap it. So what we try to develop is not a fully featured feature, but a more experimental thing to test the waters. And then if the metrics say that's okay, that really adds value to the product, then we are develop the full thing. How often we refactor? That's a good question, because I've been really thinking about that lately. Some parts of our code base are really old, and they need refactoring. But I don't know. It's like you have to think about where you need to spend your time. If the most important objective of the company is to push forward with new features, then obviously you starting refactoring things is not going to be the best use of your time, I think. So I think it has to align with what the team is trying to do. So I think, yeah, I think it's a concept to me. I don't know if that exists, but yeah.
Very short. Okay. I'm only going to quote from the pragmatic program. Refactor early, refactor often. It will save you time. Don't tell your boss that you're refactoring because they think it's a waste of time, but actually it saves them lots of time because if you won't do it, I think the term is technical debt. You owe it with interest in the future. So since you are working with it, do it when you have a chance. It's going to be on tidbits, very small, very fast. That's it.
Yeah, so basically, as I said earlier, for refactoring, I mean, the most important part is the interface. So as long as you keep the external behavior quite similar, then you can change it internally. Well, in fact, you're going to see it from the startup to going to a scale of Twitter. I mean, Ruby was just fine at the beginning, but we basically changed most of our code to Scala. So we're not talking about just like simple refactoring. It's just like taking the whole code base and just changing it to another language and adding all sorts of different features. A lot of the things though were still like similar in nature, and the interface was similar, but yeah, refactoring is happening all the time.
How did you do this change? Manually, or did you use some kind of tool? Did you build some kind of tool to switch languages?
No, it's mostly manually. They're actually hiring people that know Scala very well, and yeah, they just did most of it manually.
No.
It's intense, and I mean, there's still some parts that are being done. I'm helping on some. There's still some parts of Twitter that are Ruby or some other languages that don't make sense anymore, and I'm actually working on some decomposition things there as well. So it's intense. Some of it can yeah, refactoring can be like really like mind-boggling and like tiring, but I mean, you need to do it. You need to do it to make it more efficient, more scalable.
Thank you, Mihaly.
Thank you.
Okay. Before we move on to the networking part, I want to thank you, Alexis and Dimos, of course. I want to call up to the stage Kostas Sisamos. Kostas is the founder of Kino, and he has a very exciting announcement to make.
Hello, Kostas. I'm coming from the company Gino. We have humble meetings. We are not coming from big companies like Twitter. We work from Saudi Arabia or from NASA, and we are coming from Cyprus. And when we develop started in 2004. We are able to develop a infrastructure for it. But of course, that's a mechanical stuff, which what interests you. Personally, I am a mechanical engineer. I did some programming when I was at the university with Pascal, and I only know simple stuff. There is, we are now moving to the third generation of construction. And this is robotic toys. Now, robotic toys, which I will show later, is a project that we have run for 4 years now. It was funded by the Research Owner Foundation, and now the continuation is funded by the Ministry of Industry. We are glad that finally with our version that we go in the stores next week. Now I will go as why is it about engineering? I used to be a teacher in the primary school, and I used to teach design and technology. Now children in the design and technology with models, and then they try to animate the models by putting models and gears. In the recent years, they also added robotics, especially in the secondary school. But from 2014, robotics is going in the primary school as well, especially in the education system of England, but in England it will be all over the world. Now, we have identified there are two types of robotic systems. The first type is C4, where you can control only outputs. And the more complex systems, you can control outputs, but you also have inputs with sensors. The simple systems, they rely on graphical experience, and they are more applicable for learning children. And the more complex systems are more abstract, so they need high-level
of thinking and logic. In the primary school, there are a few products, very simple products, only with outputs. Therefore, we have introduced a new product last year. They call it WeDo, with one sensor and a motor directly connected to the computer. It does not work as a standalone product. In high school, we are using some other stuff that are inputs and outputs, and then in the university level and for home, we have more complex like online stores. Now, because of the huge demand for robotics and education, there has been a push in the lower levels of education in the primary school. There are no appropriate products. So what they are trying to sell is Lego milestones, for example, and more complex products that are not actually appropriate for younger children. So we found a gap in the market, and we have developed a product that is directly developed for the younger children. Now I will go over it a bit faster. This is the endpoints. It controls only the outputs by manual programming. This is used in the primary schools in Cyprus, in all schools for the last 5 years. The company which manufactures this has stopped producing, and now the schools ended up with products that are banned and cannot replace. This is a low-cost product, around €30. It doesn't have any peripherals, so you have to buy your own peripherals and adapt them to be connected to this stuff. For the high school, they have this type of controls. Again, they have no peripherals. And in high schools, the video, they have Lego milestones. That is a more complete system. Therefore, we have no 3D DV, which is the advanced version of ENTICE. This is a more expensive, around €350. And then a bit more complex robotics for hobbies like Arduino and others. This is the Gino robot platform. Our innovation is that we developed our own software, and we also developed our own embedded software for the controller. The GUI software has been developed to approach programming as a method of teaching. In fact, we filed last week a patent for the particular teaching methodology. The first level is to program manually, so that children can have an immediate practical perception of how to program. The second level is to program through the software running a simulator. The third level is to program with a flow diagram. And the fourth level is to program with a test. Now we developed a software that you can see in the screen. This is a software with windows. In the main window, we have the same image of the controller so that children can program manually whatever they can do on the actual device, they can repeat it on the software. Now immediately while they are pushing the button, they can see their program being constructed in the other windows. On the one side, we have a flow chart based on icons, and then on the bottom side, we have a text-based pseudo language so that they can understand coding at the early level. One of the innovations is that we have incorporated Wi-Fi communication, and today we will show you how this is working now. It is actually programming with my mobile program, the robot. This is a real time, it's not actually being programmed, just like a remote control. We can also put in a program mode, and whatever moves we are doing, the moves will be recorded and can be played later. So we can also add a few sensors. For example, this is another robot we finished 2 days ago. This has been programmed from here. So if you push, I have to start it. So we have sensors. If you activate the sensor, they run for some time, and we have another sensor. So we have infrared sensors, we have touch sensors, and our software has a particular method, not only for teaching, but also for programming. We call that the usual loop programming method with each statement is very complex for young children, especially, for example, you want to do something like this. You press one sensor, something happens, and then you press another sensor, something happens at the same time or one of the other. Then you have a loop within a loop, and this is a very difficult concept to teach to children at the age of 8 or 10. So what we have developed is a sort of with previews and after previews like you find in the PowerPoint presentation. So you can have, for example, a program here, you call it for a model, and then you call for another model, and then you define start with previews, and then you have a parallel function with the program. And with the same philosophy, the different loops while this version will go in the schools in the stores this Christmas, and we'll go to having tested by, this is the question before, how do you test the platform and the software? We find so far a few bugs. This is a continual testing procedure. The problem is if we delay a product, put it in the market too much, by having perfectly tested, we will never put it in the market. So at some point, the companies have to make a decision whether to take the risk and put the product in the market with a few bugs and keep on improving, or they delay until everything is perfect, but by that time, some other company or many companies will put their product in the market and we will lose the market altogether. So thank you for listening.
Thank you, Kostas. We actually questions?
Τι μέση,
Υπολογίζουμε θα βγάλουμε στην αγορά δύο we shall put in the market two editions. One edition will be without the Wi-Fi, and the second edition will be with the Wi-Fi and a third model and more sensors. And we expect the price for the basic edition to be around €150, including radio, software controller, and 2 infrared sensors and 3 LEDs. And the Wi-Fi edition will be at €200. This is another market decision we have to make. I did the costing analysis a week ago. Lego, for example, they launched the EV3 at $350. It was launched just a few months ago. Actually, Lego, they visited us at the last February, and the developers came, product manager came, and they took more pictures of our product. And we see now that they incorporated some stuff like remote control programming and manual programming that we have in the past. So that's why I'm saying if you delay to put a product in the market, someone else will come and take the place. So if Lego is selling at $350 and they have a brand and Lego, then we cannot sell at the same price, and we have to be at least 40% lower. And even though we do not manufacture in high volumes, so we have to sell at that price that will attract the customer. This is one problem that Cypriot companies have, and also companies have. They do not have the distribution channels, they don't have the branding, but they have to be able to sell at much lower price than the established brands. So the expected price for this is 150 euros for the basic edition and 200 for the Wi-Fi edition.
So you don't have patents for this one?
We have applied for a patent on the software and the teaching methodology.
So anyone could basically copy it, like Lego did.
They can copy, Lego they didn't copy. They can copy a function that is not patentable. If they copy something that is patentable, when we have the patent issued, maybe in 1 or 2 years, then we can go back and sue them and claim damages.
But you still don't have your patents.
So we have an application.
Just an
Patent
application.
takes a few years to be issued.
And any orders, or any pre-orders, or letters of intent?
We had a big pre-order 8 months ago from the United States, but because the product was not ready in time, now we lost an entire year because this is being the distributors order 1 year in advance, we said it for Christmas, so we expect the orders to come in the next 2 or 3 months of the next Christmas.
Can you define big order, or do you mean how many pieces?
The pre-order could be from 1,000 pieces to 10,000 pieces. Now there is an expression of interest from Radio Shack. It's a big chain in the United States with 4,000 stores, and they wanted to see the product in last July, but unfortunately we were able to send the sample only a few weeks ago. So it's very vital to be in the market at the right time and with the right product.
Okay, any other questions? Okay, one more question, last one.
Since all here are programmers, do you have a need for programmers?
Actually, I was listening to the answers before the questions. We have a big problem with programmers because we have a very small team. The program has been built for 4 years now, so other people replace other people who have a big code that very few can understand. So now what we are doing is trying to find the experienced people that they can do the debugging and fix the code and make it more appropriate, while at the same time develop more software, especially smartphone applications, so that this program will run not only from the PC but also from Apple and Android devices. So if any of you
How many here are developers?
develop something for us, we are welcome to visit us.
Thank you. We actually have the prototype of this robot at Cyprus. They last September, and the kids managed to be able to program them in less than a couple of hours, and they had it was some fun. So that's a good product, I think. So before we move on to the networking session, thank you for coming. If we want to get feedback, because it was the first event of this kind, so if you have any feedback from anybody of the team, if you are shy, just send us an email at hi@percel.com. And also, next Saturday, we have our Berkeley's VR networking event.
This Saturday.
This Saturday, yes, okay. This is what I meant. Go to the Facebook page and you can get a ticket. It's free, but they are running out, so hurry up. Thank you for coming. Merry Christmas. And we'll be outside. We have pizza, we have beer. Thank you.